until now to take a dark field correction, because I was playing with all those adjustments to show you the features of what to do to get a good image out of low exposure settings. While I'm showing you this, the camera is warming up and it's developing heat a little bit. And that heat will show you a little bit more hot pixels, a little bit brighter warm pixels. And by the time the camera's warmed up, now you're ready to take a dark field correction. It'll take it at the warmest stage of the camera, and you'll be good to use it all night and for future use and other nights that you're going to set up. As long the exposure matches pretty close to what you have. Now, Alistair, I don't know if you're still on or not. I'm going to show you something. You were worried about the exposure. The beauty of taking a dark field correction is not like a dark frame. If this sensor would be a progressive sensor, I would have issues that you brought up earlier. You'd get little black dots, you'd get little white dots, and whatever else. That means you would have to have a huge library of dark frames. Here, these are called dark field correction. We're taking a dark frame of each field basically, but it's a dark field correction. And when the odd and even fields are joined together to form an image, everything is smooth, and both dark field correction has been removed instantly. This is happening instantly. What I'm going to do for you, Alistair, is increase exposure. Let's make this thing look ugly. Let's go to 20-second exposure. Folks, the image is going to look ugly, and this is what I want. Let's go 20 seconds. Oh man, this is going to be ugly. Now, why am I doing this? Just to show you the dark field correction, how it works. Although I took it 10 seconds, if you go to 20 seconds, it's not going to matter too much. It's still going to be useful. You could probably go even higher than that. And that dark field correction I took is still going to work. Here's the thing though, the dark field correction. I just opened up the tab on the right. You could select 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And it will stack and average them to give you even better dark field correction. I only took 2 to show the actual difference. But I'm not going to take 10 of them. I'm going to put back this number 2 where it was. I know that I've got my dark field loaded. Now what we're going to do is come here, put the gamma back at default, because now we really got a bright background. Although I don't have a dark field correction activated, look how clean that is. This is a single exposure, folks. This is not co-added to get rid of the noise. You do not need to co-add with this camera at all. None at all. Mind you, my tracking's not good, but wow. That's pretty ugly, isn't it? Now, if you look on the upper left, look at the upper left. There's a star with lines in it. Co-adding images, stacking. So the update is going to be every 40 seconds. But look on top, Alistair, left upper image, that bright star, it's got lines in it. Wow, well, what happened here? There you go. That's because the mount has moved between the odd or even field frame. Now, it took another... just to show you, this is a real video camera. It continuously takes an image. Now the mount decides to track properly, and the odd and even field got joined together, and the star is nice and round. Did you get that, Alistair? Am I still on? Yep. Well, that's correct. Alistair. Hang on, Alistair. I've got this set up at 20 seconds. Because it's an interlaced, and because it's split interlaced, so we can use the dark field correction. At 20 seconds, it has to take half the information, which is odd field for 20 seconds. It saves it to the memory. And then it has to take another 20 seconds of even field, but that's only half the information. 40 seconds later, because it finally took the odd field, it's going to put the two of them together, interlaced. So it takes 40 seconds for that to happen. So 20 for the odd, 20 for the even. Once it's done, boom, it assembles the image instantly, and here's your image. You cannot take both of them at the same time. You don't want to take both of them at the same time in this case. That's why I keep saying you don't need to go long exposure, Alistair. You don't need to go to 40 seconds and 1 minute and 2 minutes exposure. You really do not need to. That's the point of this broadcast tonight, is to show you how to keep your exposure short and use the gamma and the histogram to recuperate this gain that you need to see the image without noise. Naming a matter of naming the software. Good stuff, Sam. Thank you, Sam. Okay, Alistair, I don't get it. The question is just a matter of naming by the software. Oh, thank you, Jack. Man, I need to go hang around with you, Jack. Obviously, my French education gets in the way, Alistair. It's correct. Jack is dead on. The physical data forming the image is 20 seconds per field. Not 40. It's 20 seconds. But to assemble both of them after the odd field is taken, well, it takes 40 seconds in all, because it held the first 20 seconds in the memory, and then from the odd field, and then the even field after it's been taken, well, now it's going to assemble the image and show you right away. So your refresh happens every 40 seconds, but the actual exposure is 20. Well, because it's not 40. Okay, you're saying, I mean, the exposure is 40. Why not call it the software 40? Well, because it's not 40 seconds. Why take a 20-second exposure and call it 40? I don't get it. We split the field. You told me once here on NSN a year ago, you knew everything about video cameras, and you made a point of it publicly. Well, now it's my time to tell you about it. I split the field. Odd and even are split. They're divided. But odd field allows you to have half the information, which you saw earlier with the lines, because the lines are there because you're missing the even field. So it has to take another 20 of the even field, assemble it, and the data shows you the final 20-second exposure, but it takes 40 seconds to show the image. It's just a question of refresh. So you take a 10-second exposure, or 20-second in this case. All right, we got the 20-second going. 20-second is for the odd field, which is half the information. After it's taken, the information is held in the memory of the computer, and now it has to take an odd field exposure. So it has to take a 20-second odd field. Once it's done, it held that 40, that 20, that previous odd field was held in the memory for that 20 seconds, and now the odd field, the even field is going to show after another 20 seconds. Once it's assembled, you're going to see the result in 40 seconds. It's not a 40-second exposure, because the odd field, you're getting it at 20 seconds, you're missing half the information, you're missing the even field. That's why you need to take another one of even field to fill the lines, to fill the information you're missing. The exposure is still 20 seconds. It's just to compilate those both together. The refresh, the final result, will be shown in 40 seconds. That's correct.